Start. So today, I will be problems related to ordinary differential equations problem. Let me write example 1. Suppose you're asked to solve 2t plus 3 y prime plus t squared plus 1 y equals 0. Now, the first question I want to ask you is this. Looking at this problem, what kind of differential equation it is? Is it linear? Is it non-linear? What do you think? And what kind of order it is? Exactly. It is first order linear differential equation. And why do you think it is linear? First order? Yes, that's very correct. So that's actually the reason why. So you could see the y over there. You could see it's having a power of 1. So when for it to be linear, you need your y to be in that form. If you start having y equals y raised to 2, y raised to 3, y raised to 4, then it becomes nonlinear. But for this case, you are having just y. So y raised power 1, it's linear. That's what makes it linear. Then your y prime, since it is the first derivative, first order linear ordinary differential equations. So, and knowing that helps you to streamline the method you are going to be using. Since you know it is a linear differential equation, you cannot be thinking about using Bernoulli. Yeah, because there is nothing non-linear about this. This is linear. So, which means that maybe one of the things you should know about linear equations mostly is that you can use what we call integrating factors. You've been taught in class. So whenever you have, oh, this problem is first order linear ordinary differential equation, then most times we make use of integrating factor. Yes. So let's try to solve this problem. Solution. We said this is linear first order ODE. Take note. Because I don't know, maybe in your exam you might be required to tell what kind of differential equation it is. This is a linear first order ODE. So this means that we can rewrite this problem as, let's say, y prime plus t squared plus 1 over 2t plus 3 y equals 0. Right. And this is because since it is linear, you know how linear ODE looks like. Linear ODE looks like this. It looks like, let's say, y prime plus, let's say, p of t y. For this case, it's you can have q of t. This is an instance of a linear first order ODE. But considering the case which we are dealing with, it means here that q equals what? Q is what? 0. Exactly. Q is 0. Q is 0. So this is how linear first order ODE looks like. Please, I'm repeating this over and over again so that it can stick, because I've been a student also, so I kind of understand how things work. So that's why I'm kind of repeating it almost every time, so it can just stick to you, because they are fundamentals, they are things you need to understand to solve problems. So now that's how the linear first order ODE looks like. Now we're able to express it this way. And the question is, why do I have to express it this way? So whenever you are dealing with linear first ODE, try of this form, of the form I wrote there, then you should try using integrating factor. Okay. So if you remember your integrating factor was written as um, mu equals exponential, remember, integral of p of t dt. Is that right? Yes. This is your integrating factor. Sorry. So using integrating factor. So this is step by step for you to understand the logic between why we are not using any other method, but we are using this one, integrating factor. I already told you when you're dealing with that kind of expression, then you should use integrating factor. Now, if you use integrating factor, what is our P of t in this case? What is our P of t? T squared plus 1 over 2t plus 3. That's P of t. So that means that my integrating factor becomes exponential integral of t squared plus 1 over 2t plus 3 dt. Yes, so in order to solve this kind of a problem, I can so I'm going to solve this. So let's say u equals 2t plus 3. So if you let u equals 2t plus 3, that means that the u dt is what? What is the u dt? Equals 2. So this implies that the t equals the u over 2. And from here, you could have that your t is simply what? U minus 3 all over 2. Yeah, so now you can try substituting it into this place. I won't do much on that. So, but I'm just going to give you what you're going to get. So let's say that you have mu. So this means that your exponential into bracket integral of. So this means I will be having u minus 3 over 2 squared, right? Plus 1 all over what? 2u minus 3 over 2 plus 3, right? Multiplies with the u over 2. So we're not doing any magic. We are not doing anything there. We are just substituting, which I believe you followed till now. So when you simplify this problem, when you simplify this, everything that you have in this bracket, then you have your um you will obtain the integral of u squared minus 6u plus 13 over 4u multiply with the ut, and this gives us 1 over 8, exponential, yeah, exponential 1 over 8 integral of u minus 6 plus 13 over u du. So I'm writing these out because I don't need to start calculating and uh, doing addition and subtraction for you. You should be able to do that. But once you do, once you do the right, just simplify what I've written there, you will arrive at this other solution. And from this other solution, you will arrive at that. So I'm able to, so I believe you understood what I did here, I believe you understood, sorry, what I did here. I believe you understood what I did here. So what I did here was just what I did in the last class, where we use polynomial division. And the reason why we are using polynomial division is to be able to simplify and so that we can easily integrate. Because you can't easily integrate this, what do you call it? Um, or even if you are not using polynomial integration and polynomial division, you can obviously see that this is the same thing as saying u squared over 4u minus 6u over 4u plus 13 over 4u and multiply with du over 2. So 1 over 8 is simply by multiplying the denominator. You can see 4 multiplied by 2, that's 8. So you have 1 over 8. Then you discover u squared over 4u will give you u over 4. So that's simply, so u over 4 multiplying 1/2, that's u over 8. Please, do you follow that? Yes, so that's how it is done, in case you're trying to look what we've done so far. So our final answer, when you integrate this, so can you integrate this? This one will be exponential. So if I integrate this guy, I'll get u squared over 8. Uh-huh. Uh, no, I'll get 1 over 8. Sorry, I will get 1 over 8 u squared over 2, right? Negative 6u. I'm just integrating the inner bracket, and that is u squared. If I integrate u, I get a u squared over 2. Then if I integrate negative 6, then I get u, or absolute value u. Exactly. So we get that. And then you can expand. If you expand, so this will give you exponential um, exponential what? This will give you exponential. What is our u? 2t plus 3. So this is 2t plus 3. So 1 over 8. 2t plus 3. Squared over 2 minus 6. 2t plus 3 plus 13 natural log 2t plus 3. Yeah. So our y of t, don't forget this formula. Y of t equals to the integral of q of t, I think. Dot times I of t, I of not the t, think plus c. Yeah. So if you remember this formula, this is what y of t multiplies your integrating factor equals your q of t. You know what your q of t is in this case. Our q of t is what? 0. So that simply means everything in that integration part, everything disappears except your constant, arbitrary constant c. So that means that my formula, my final solution will be what? Yeah, this will be y of t multiplies with integrating factor equals c. And then don't forget our integrating factor. This is our integrating factor. Our integrating factor is this. And so it means that y of t equals c over your integrating factor, mu, where mu equals this guy. And so you have C exponential negative, right? 1/8. Everything you have here. That's your final answer.